Hello everyone, welcome back to my YouTube channel Cloud and AI Analytics. Hope everyone is doing good. I'm Vignesh, and in this video we are going to implement a real-time use case inside Google Cloud Platform using big data services like GCS bucket, BigQuery, Dataflow and Cloud Composer. So this particular use case which reads data from cloud storage bucket, implement the business or transformation logics on the data using Dataflow's Apache Beam Python SDK, and finally the transformed data will be written inside Cloud BigQuery, which is further used for analytic purpose. So this entire pipeline is orchestrated via Cloud Composer's Apache Airflow. So this is the use case, and without any further delay, let's get started. So before proceeding further, I just want to let you know that this particular pipeline is implemented on how we will implement as if in the real time. We will not touch console for any reason, right from enabling the APIs till creating the service and running the pipeline and deleting the pipeline. Everything is orchestrated via Cloud Composer and everything has a separate script to it. So this is how we are going to implement it as well. And now I'll walk you through the code. First, here you can see under this folder, setup composer GCP, right? This is where we will set up the GCP resources. For example, right from configuring the project, enabling the APIs, and the third one is creating the cloud storage bucket. So everything is happening via gcloud commands. And once after creating the GCS bucket, then we will create the service account. The name of the service account will be here. Here you can see line number 11. I have defined it. Composer Dataflow SA. So this is the service account which we are going to create it here. And once after creating the service account, I'll be associating the roles to this service account. Roles such as composer.worker, dataflow.admin, dataflow.worker, storage.objectadmin, and BigQuery data editor and BigQuery job user. So these are the roles we'll be associating with this particular service account. And we are not going to stop here. The next important point to note is this entire pipeline, right? We are going to execute it as a both service account and also user account. So we are going to associate the user. The user will be Azure Learn Demo @gmail.com. This is the user email, and I'll be associating this user email to the service account email, that is Composer Dataflow service account, and I'll be giving the role service account user to this particular user. Another important point to note is like Composer internally calls another service, that is Dataflow, and both the service, like both the Composer and Dataflow, it will use the same service account. So the service account should also have the service account user role. So I'm binding that role to this service account as well. So these are the roles we'll be giving. And the next point is we'll be creating the composer, and then inside the composer we will submit our DAG job. On all the steps we'll be following further. So this is the setup, and now I'll just get into this gcloud composer create.shell script. So basically this is how we will be creating the composer environment, and the name of the environment will be demo composer 3. Here you can see the service account, composer dataflow service account, which we created in the previous step, right? The same thing we are using it here as well, and the project ID we are getting it from config get value project. So first I'll explain you the steps, like I'll explain you the code, what it is doing, all those things. I'll just give you a quick walkthrough, then I'll show you implementation as well. So this is nothing but like creating the composer environment. So location is your central one. The image version, like basically this is the composer 3 image version which we are going to use for this demo purpose. Service account is composer dataflow service account, project ID. The labels like environment is dev, team is cloud AI analytics, and this all the other details of this cloud composer. Now I'll walk you this in the composer environment. So I'll directly go to the console and search for composer. So I'll just click on this composer. I have already enabled the API, and this is the service which we are going to use for this demo purpose, but I'll show you how it is. So here you can see composer 2 and composer 3. This is the latest version, and I'll be using this for this demo purpose. So here you can give the name of your composer, the location, the image version. Here you can see composer 3 airflow 2.10.5 build.16. So I'll be using the latest image version as well. And next, the service account, that is composer dataflow service account, which you have created for this particular use case alone. So I'll be using that, and labels you can add it here like key value pair. And the next one is resilience mode. Like there is two, high resilience and standard resilience. So for this demo, we can make use of this standard resilience, that is more than sufficient, but I just wanted to experiment in high resilience as well. So I have selected the same. Here you can find line number 15, enable high resilience. And the next one is the environment resources like small, medium, large, and custom. So here in this demo, I have used medium, which has two scheduler, two DAG processor with two virtual CPUs, 7.5 GB memory, 5 GB storage each. The next one is trigger, web server, all the details. Same I have given here as well. Environment sizes, medium, all the details. Whatever you see here, right? The same details, you'll be able to find it there. The network configuration, like it is running in the public network only, and under advanced configuration you can find all the other details as well. If you want to set the environment variables, you can add it here, or if you want to add airflow configuration, like if you want to override any particular configuration, you can set it there. And access to public PY packages, if you want, you can add there as well. The environment bucket, so I'm going to use the default bucket, which means the composer will be creating, right? I'll be using that same. But if you wanted to use a custom bucket of your choice, you can obviously use that as well. The data encryption, maintenance window, all these details. So this composer environment will take around 20 to 25 minutes to be created. So that is why I have created already. But the command are same. The commands are everything same. You can just execute this. The next one is Cloud Composer delete. Since composer is basically a costlier service, right? Once the demo is done, you have to make sure that environment is deleted. The composer environment is deleted. So this is where all the three files, right? This file is most important because this is where we are setting up the environment. The next one is obviously we are creating the composer environment and deleting it. So this is basically how we are setting up our composer environment. And the next we are going to talk about the data, basically CSV file. This CSV file I'll be uploading inside my cloud storage bucket, and this is basically a retail data which has details about the product, category, quantity, price, customer ID, and store ID. And also we'll be doing some business logics on the data, and we'll be deriving our own columns as well. So we'll be seeing that while we're explaining the Dataflow script. And one important point to note is that though it is a CSV file, right, it is not a comma separated, instead it is a tab separated. The next one I'll talk about is DAG. So everything is configured via YAML file. So I'll talk about the YAML file. So first you have to set the project ID, the region, what is we are going to use the stage bucket, like basically the bucket which you are creating in the first step, right? The same bucket I'm using it here, and the Beam script path and input file, like basically the data file. And the next one is error output prefix. If there is any error in the CSV file, there is a particular logic on that. If there is some error, make the pipeline error one. Instead, we will capture that error and we will save it in the GCS bucket. And the final thing is BigQuery. This is where we will write our transformed data, and the retail data set, and the table name will be sales summary data. So one important point to note is in setup composer GCP, right? In this particular setup GCP resource, if you have noted, I have created cloud storage bucket, but I have not created any steps in order to create the BigQuery dataset or table. The reason being is during the Dataflow Apache Beam Python SDK pipeline, right? During that step, the BigQuery dataset, BigQuery table, everything will be created. And if the pipeline is running on regular basis, right, like it will check, and if it has any new changes, it will update, or else it will just use the same existing data set and table. That is the reason I have not created it there. And the BigQuery table schema. So this is what the schema where our final table will look like. Product name, category, quantity, price, customer ID, store ID. And these are the two derived columns, basically total amount and sales category. And the next one, DAG Beam GCS to bq.py. This is basically our DAG file. This is where we have implemented the orchestration steps. So one important point to notice, I'm not using the direct function operator. For example, you are using Dataflow, right? I'm not using Dataflow Python operator. I'll create a separate video on that. But I just want to use bash operator and execute that Beam script in this operator. So that is the idea, and I have given the same. I have done the same here. So the next one is configuration. Like I am configuring this YAML file here. And the next one is like get all the configuration from this particular YAML file. and that YAML file is present inside this GCS bucket, right? So I'm importing all the required storage client libraries as well, like GCS storage client. Here, if you see line number 25, the next one is I'm calling this function, I'm passing this GCS config file path, and I'm assigning variables to this values. For example, project ID, like GCP project ID, region, staging bucket, Beam script path, and Dataflow service account as well. And these are the default arguments, like who's the owner, start date, retries, it will retry for only one time, retry delay after 5 minutes, and Dataflow default options. All these variables we are reading it from this YAML file only. Now we are defining the function like DAG. So basically the DAG ID will be retail sales GCS to BigQuery, the default arguments, whatever we are defined it here, we are calling it, and the schedule is, it will run every year only once on 17th July exactly at 12 a.m. That is what I have scheduled this. This is just a dummy value. So I have scheduled it on July 17th every year. And catch up is false. The tags and the document, all the what, this is basically a document string. If you wanted, you can add, or you can just. The next one is start pipeline. So basically I have used empty operator as well. So basically I have two empty operators. One is start pipeline. The next one is end pipeline. It doesn't do much, but the main core of this particular DAG is residing inside this bash operator. So bash operator, the task ID, and I'm calling this GCS Beam script path. Basically our basically our Beam pipeline. And what is the runner, what is the project, region, staging location, temp location, the job name, service account, and the config file. So I have passed everything. The reason why I passed the config, right, because all the schema, BigQuery table, everything is to be passed from config YAML file to the Apache Beam Python SDK file. So that is why I have passed all the values here. So in this bash operator, there is one important thing to note. We are not using a direct Dataflow operator, right? We are not using Dataflow Python operator. If you are using Dataflow Python operator, then the script path, basically Beam script path, right? I have to upload that inside this GCS bucket, and I have to directly point that GCS script path basically. But I'm not doing that. Instead, I'm calling this bash operator. Inside bash operator, I'm executing it as a Python command. So I have to upload this Beam script path not inside that DAG folder or inside a separate folder, or I should not point it to GCS bucket the same way how I'm pointing it here, right? For example, if you see input file, I am pointing directly GCS file path. This is GCS file path, but the GCS Beam script path, I'm not pointing it as what you see here. I'm not pointing it to GCS file path. Instead, I'm uploading it in this home directory, home Airflow GCS data. So I'll show you where it is, but this is one important point to notice. So as of now, I believe everything is clear. Now we are getting into the important logic, that is the Beam script file. This is where we read data from GCS bucket, do some transformations, we create two columns, and then finally write the transformed data into BigQuery. And this is orchestrated completely via Cloud Composer. And here you can see I am importing all the libraries. Import Apache Beam as Beam, import Apache Beam.io, read from text, because we are reading it from GCS bucket, and BigQuery, write to BigQuery and BigQuery deposition, and basically the pipeline options. I'm importing logging, and the next one is importing RE, that is regular expression, in order to do certain transformations as well. And the YAML file, we are reading the YAML configuration here as well. So that is why I'm using the YAML. And the next one is BigQuery storage, and this is basically for exception. So these are the libraries which we are importing for this purpose. The next one is get config from GCS, the whatever we have discussed in the DAG file, the same function. Now I'll talk about all these things. Like here, this is the main function. Def run is the main function. And the first option is like it is getting all the arguments from the config YAML file. So here you can see we are loading all the configurations from the YAML file, and then we are passing it to the next other options as well. First we have to check that this is basically a simple check whether a GCP project ID is valid or not. It's the dataset ID. Like here you can see BQ output table dataset. The same thing, if you go here, find here, right, you will be able to find this. This is the dataset. We are configuring that dataset, and we are trying to create whether the dataset is already present. If it is already present, we are not creating it. Here you can see the dataset already exists in the project, so we are not going to do anything. But if the dataset is already not present, then we are creating that dataset in that particular region. the region which you are passing is US central one. Then once that is done, the next one is BQ output table, GCS input file, and GCS error path output prefix and the table scheme. This is where our pipeline starts. So with Beam pipeline, option is pipeline options, whatever we have passed, right? Basically, we have a lot of other options as well, like project, region, staging, location. These are the pipeline options. We are passing that. So we are reading it from GCS bucket. We are skipping the first line. And the next step of this particular Beam pipeline is past results. Basically, we are taking this input and we are passing it. Like as I mentioned earlier, this is tab separated values, and I'm using this method pass.csv. So I'll go there. Here you can see pass CSV line and tuple dictionary. Like it takes and it splits based on the tab, product name, category, quantity. It assigns all the values and it returns. And once the pass result is done, then we are filtering it on good records and bad records. That is as part of this pass.tsv. If there are any records which is of basically bad, right, or basically it is incorrect, we'll add that in the bad records. If there is no error, it will come under the good records. And finally, this is where we are doing some transformations. We are applying some transformation logics, like we are mapping, then filtering, and then finally we are doing some calculations like add total and category. This is again a Python function. It calculates total amount, that is quantity and price, and based on the total amount it differentiates or it categorizes sales as high, medium and low. That is based on the total amount. This is a simple business logic, or you can consider that as that. And we are doing on the top of this good records. We are not doing anything with the bad records. Once this calculation, the transformation is done, finally we are writing the transformed data into BigQuery. The output table, we have defined it in the config YAML file, and the schema is also taken from YAML file. And basically for this, we are doing it for the first time, it will create if needed, and then after that it will append to it. And what we are going to do with bad records. So bad records, obviously again we are mapping it and writing it to GCS bucket, and this is the error, or this is where our bad records will get into. Basically inside this bucket we will create a folder errors and the bad records will be inside that. So this is what our Apache Beam pipeline is going to do. Basically it extracts data from cloud storage bucket, do some transformations, and finally write the transformed data into BigQuery. And this entire pipeline is orchestrated via Cloud Composer. And this Cloud Composer is basically scheduled only once in a year, that it will trigger on July 17th every year at 12 a.m. So this is what our pipeline does. Now it's time to get into the action. So first what I'll do is I'll just go here, go to this setup connectors, GCP, setup GCP resources, and you can just come here and you can modify the values here. For example, my bucket name, I'll just keep it as 1. I'll just keep it as 1. And the dataset, let it be retail dataset. Service account name, I'll again go with 1. And service account email, it will get it from, and the project ID. So it will enable the API, it will create the bucket, all the details. So I'll go to cloud storage bucket and I'll show you what is the bucket which is available there. So you can just click on this bucket, and here you can find this is the project ID and the data bucket. As soon as I execute this pipeline, right, you will be able to see one more bucket in the name, the same name, but it will have one appended to it. So here you can see this is my bucket name, project ID, data bucket -1, and this service account, basically Composer Dataflow as well. So I'll just go there. The Composer is, sorry, service account also I have already created. So I'll just click on this IAM admin, and then you will be able to, yeah, here you can see this is my service account, Composer Dataflow service account, and all the required roles, all those things you will be able to find it here. I'll just comment this out because I don't need it. The reason why I'm commenting it out, right, because it will take 20-25 minutes to create. I have already created the Composer environment, so I'll make use of that. So you can just go here, get into that folder. So Composer GCS, right? So Composer GCS to BigQuery and setup. And you have to just execute chmod +ex and just give the file name. That's it. It will give all the required access, and you can just go and execute this. So once after executing this, what it will do is Here you can see the active configuration, the project ID, the region, bucket name. Here you can find the bucket name, BigQuery dataset, and the service account name. You can see those service account name as well. And it has configured the project. Next, it enables all the required APIs. The next one is it is creating GCS bucket. Here you can see bucket is not found, so it creates a bucket. And the service account, it again service account is also not found, so it is creating the service account and it associates all the roles to it. And as I mentioned earlier, like our user email and also the service account will both have service account user role. I'll show you that as well. And finally, every step is done. So now I'll go to IAM and I'll just click on this refresh. So here you can find the other service account in the same name, basically in the different name, obviously. Composer Dataflow service account. This is already existing one, and this is the one which is created newly. Composer Dataflow service account, and you can see data editor, job user, Composer worker, Dataflow admin, Dataflow worker, and storage object admin. Now you can just get into the service account, and this is the service account which got created now. Just click on this, get into this principal with access, and make sure the Azure demo @gmail.com as service account user. Obviously, the service account which we created now, that also has service account user. This is very important and it is a mandatory step. The reason why it is because our Composer pipeline internally calls Dataflow, and both Dataflow and Composer has one service account, which is nothing but Composer Dataflow service account. Now it's time to execute our pipeline. So I'll just go to Composer environment as well once. So this is my Composer environment, which I created via the same script. So you can find the details as well. The logs, DAGs, basically the DAG is one. Environment configuration. This is basically all the configuration related to this particular Composer environment. The name, the location, service account. Here you can find Composer Dataflow service account. The image version, Python version, DAG folders, Airflow web UI. You can just click on it. It will get into the Airflow web UI as well. I'll just execute. I'll just click on those details, and you can find all the other details as well. And if you want to edit, you can edit it as well. And Airflow configuration override. If you want, you can configure it as well. Environment variables. If you want, you can set it here as well. The labels, basically key, environment, team, and dev is retail. Sorry, basically environment is dev and team is retail. And py packages, if you want, you can install it over here as well. And if you want to save it as a snapshot or load a snapshot, refresh, delete, you can obviously see it here. And once I click on this Airflow UI, here you can see the DAG file, which our main DAG file is whatever the file which you have executed, right? Like this is what the DAG file is. Retail sales GCS to BigQuery. The same thing, you will be able to find it here. Retail sales GCS to BigQuery. And the next one is the GCS bucket. So inside the GCS bucket, like this is the bucket which was created by the Composer environment only. So here you can see DAGs, data, logs, and plugins. Inside this DAGs, we have two files. One is DAG file. The next one is the YAML file. And the next one is under data, I have uploaded my GCS to BigQuery beam.py. I have uploaded here. You can use this commands like gs util copy and copy it from here there also. So I'll just do it for one file, copy path, paste it here, and then gs, go to this DAG folder, click on this DAGs, copy this, go back, paste it here, and enter it. So the copying is done. The same you will be able to find it here. I'll just go to my, this is Composer GCS bucket. This is not the bucket which we created. The bucket which we created is different. So I'll just open that as well. So this GCS bucket is this one. Here you can see this is the GCS bucket, and inside this GCS bucket is where our files will be there. Under incoming folder, sales data.csv file is present. So this folders I have created, like this staging, temp, errors, these are created by the script itself. Now you can go back to your DAG. You can just click on this retail sales GCS to BigQuery, and this is where you will find all your DAG related details. So you can see three operators: start pipeline, run beam, job via bash, and end pipeline. And you can see the graph as well. It's very simple graph, and the code you will be able to find it here as well. So this is the code which I have explained you, right? The same thing, the code is also here. event log, run duration, task duration. You can find all the details here. And here you can see it got scheduled on July 17th every year at 12 a.m. So what is the next run? So it is next run is 2026 7/17. But if you want to trigger manually, you can trigger it, refresh it, delete it. You can do it here, and you can see all the different status. Now you can just click on this trigger DAG. So it will trigger a job for us. Got triggered. So here you can see come to graph, and here you can see run beam job via bash. You can just click on this, go to the logs, and under logs you will be able to find most of the details here. You can find all the details here. So it is still running, and you can just click on this console. It will directly open the Dataflow job. Instead of this, you can directly go and you will be able to find a job is running. So retail GCS to BigQuery. Here you can see the job name, the job ID, job type, job status, SDK version. You can find all the details like job region, current workers, all the details you will be able to find. It is still in the initial stage only. It is not executed, and you can see all the Beam plugins like file system, local, like this is the one which we are using, GCS file systems, config file. So again, the config file path is here. Dataflow service options like experiments, job name, pickle library, project, region, what is the runner, service account. Here you can see the service account is also Composer Dataflow service account, stage location, and temp location. It is still running. I'll pause the video here. Once it is completed, I'll resume it back. So yes, the pipeline is completed. Here you can see read from GCS, pass TSV and extract good records, filter none records, add total categories those and write to BigQuery. And if there is bad records, like extract that and write errors to this GCS bucket. So everything is completed, and it took around exactly 4 minutes that it is still running, but it is completed. There I don't see any error. Now we'll go to BigQuery. So we'll come to BigQuery and we'll cross check whether our pipeline is completed or the data is loaded into this data set. So retail data set and the sales summary data. So totally we had around 500 records. So if you see here, right, under data, you will be able to see 500 records, and the same you will be able to find it here. So go to this are the tables here. You can see product name, category, quantity, price, customer ID, store ID, total amount, and sales category. These two columns are created by our Beam pipeline. So go to details. Here you can see loss modified is this 22, 1050, the same time as 1052, and number of rows is 1000. So I have executed twice. So it have appended the data 500 plus 500, 1000. So it has appended the record. Next, I'll go to preview. Here you will be able to find the record. Distance based on which column? So distance based on customer ID. So distance based on customer ID, and I'll execute it. So here you can see total it has 500, and you can just go here, refresh it once, and here you will be able to see retail GCS to BigQuery bash and the detail end time. So it totally ran for 4 minutes 35 seconds, and you can just come to a DAG file, go to graph. Here you can see it is completed as well. This is completed also. So we have achieved our target. Like basically this is a simple ETL pipeline which extract data from GCS bucket, do some transformations, and finally write the transformed data into BigQuery. It is orchestrated via Cloud Composer's Apache Airflow. This is how we will be implementing it in the real time as well. So once you have completed this demo, you can just go back and execute this setup, right? So you can just go G Cloud Composer delete and execute this. This will delete the Composer environment alone. You have to manually go and delete your BigQuery dataset and GCS bucket as well. So that's it for this video. If you have any questions, please post that in the comment section. I'll take a look at it and reply to it as soon as possible. I hope by this video you have learned something. You have learned how to implement it in the real time, and I really believe this will help you in your project as well. Please do like, comment, share and subscribe to Cloud and AI Analytics. And the code of this demo will be shared via GitHub. You can find that in the description section of this video. And if you have any questions, please don't hesitate to ask. And I'll see you in the next video. Until then, it's bye from Vignesh. Happy learning.